couple things here. First of all, if I want to represent the force on something, what Newton's second law says is that force is mass times acceleration. So in order to represent the force to move an object, I need to know what the mass of that object is, right? Clearly, the bigger the mass, the more force it's going to take me to move it. And I need to know what the acceleration of that object is. Okay, so force equals mass times acceleration. Now, what this is, and let me just represent the units here. Force is usually represented, and this is a metric representation. Force is represented in what we call capital N, and the units here is newtons. Okay, so that's usually what we represent force in. Now, work is slightly different. Okay, so force is basically just the amount of pressure I would need to apply to something to get it to move. Okay, now, clearly, if I have to, that's just to get it to move at any distance. So if I want to actually move something a specified distance, that's what we call work. Okay, so if I have some box, I can figure out the force it's going to take me just to move that. And then if I want to move it 5 feet, I'm looking for the work it's going to take for that to happen. Okay, so work is basically like energy expended. So the work, well, it's the force that I need to apply times whatever distance I'd like to move that. Okay, so